Our third innovator presenter today is Srinivas Panapakkam, Vice President and Sales and Business Development at Mistral, a subsidiary of Access. Srini has been involved in multiple augmented reality and virtual reality projects and has contributed to the growth of Mistral as a leading global technology company. He will be presenting augmented reality, virtual reality, evolution, and usage for gain in productivity. Thank you, Srini.
Thank you for having me here. It's been a privilege, and thank you for the Tech Council for this. So basically, we are just going to talk about AI, VX. So before that, I think just want to tell a couple of words about Access. We have been a young company in the area, though not in US. We have been in other part of the US, like Peoria, California, and other places. But here we have been here for about a year now, and we work with mining, aerospace, and manufacturing industries, and we are very happy to be here and the responses we are getting here. Thank you so much. So what is AI, VI? So very simple way. So I think if all of us are going to be having 3 meals a day, and we are going to have AI and AR and VR in our lives, it's going to be as common as having those 3 meals a day. So that's what Tim Cook says. So if I may follow the quote. Just want to talk to you about the evolution of AR and VR here. So how it started. I'm sure that most of us in this room are aware of this, the Viewmaster, wherein like we put our holiday postcards in there. We just clicked and started seeing that. So that was actually the starting evolution of the augmented reality. And then that's when we started. And then this was like a telesphere mask, which was actually invented in 1960 by Morton Healing. So this was actually one of the first head-mounted device, and he was a cinematographer. He actually invented this so that people could actually wear this and see that like in surround sound or like a vision and all those things. So it's basically all the imagery, stereo sound. This is what was part of this. So this was actually invented in 1960, and then this was like a head side. So this was like in 1961, military used it to see dangerous situations. So you could stream from the like remote locations. So this was basically used. This is a very interesting thing. So Sensorama. So if you're driving in the lanes of New York, you're going on a motorcycle, you want to get the real life experience of how it is getting the smell of your hot dog from the street vendor, this could actually simulate the whole thing. So this is basically the Sensorama, which was invented in 1962. And then we have this Air Force Super Cockpit, which could actually put the maps on your helmet. It could lay down a lot of things. So it's like if your all the avionics data, then your all the simulated data, maps, everything can be put. So this is not AR. I mean, AR, VR is not something which happened over the last 10 years. This has been happening, the evolution is happening since 1930s. So this is 1988. This was a device which NASA used to viewing all the remote video cameras. Then this is one of the projects that we were involved in, and in fact I'm very glad to say that actually Google Glasses was actually kind of their initial design was based on this. One of the co-founders of Google Glasses, he came to CES Consumer Electronics Show in Las Vegas, and he saw this, and they actually started working on the Google Glasses after watching this design. So we are kind of, I could say this is the precursor to the Google Glasses. And then of course the Google Glasses, though it was not a commercially successful, I think the whole world talked about AR, VR, probably the people started talking more about that only after seeing the Google Glasses. So if you see the global augmented reality market, it's about projected to reach about $571 billion in 2025, growing at a compounded annual growth rate of about 63%. And then, so this is what we are looking. So today I'm going to talk mostly about the B2B. I'm not really talking about B2C because a lot of businesses, how you can actually use about B2B, this AR and VR in the B2B domain. So if you see some of the domains and applications, we are there everywhere. Like you can use it in entertainment, industrial, medical, real estate, aerospace, defense. So pretty much everything you can actually use this. So this is not just like the device. So if you see the Google Glass, it was just the device. But here what we are doing is it's going to be an amalgamation of the device, the software, the system, because you need to integrate the people, process, and the work that they are doing. So this is for the B2B that you are talking about. This has to be an amalgamation of everything over here. So this is the kind of thing I saw that today. Actually, before coming here, I think predominantly there is industrial and healthcare here. So if you see the industrial sector, they are going to be about $230 billion in the AR/VR by about 2025, and if you see the healthcare market, it's going to be about $7 billion. So that's the kind of market we are talking about here for the AR/VR. And if you see the industrial, what kind of a thing? So I'm sure that there is a crisis point. I think Amanda was saying earlier that there has been a lack of manpower. There is not enough manpower. But I think the biggest problem we are facing is the baby boomers are entering into retirement. They're already retired. You need to make use of their knowledge. And it is a proven fact today in the aerospace industry, oil and gas industry, that there is a severe lack of knowledge transfer, knowledge management. There are no people to train the people who are actually coming out of college. So AR and VR is actually an answer to that. So how do you make use of their knowledge without letting them travel? They may not be able to travel, but still you need to make use of that knowledge. So the answer lies in AR, VR. So this is the way basically you are going to use it in training and development, and things like simplified assembly instructions. So you have everything over there. So all you need to do, your hands are free. You're able to see what you need to do in your glasses so that the people are able to work on that. Then you're looking at efficient maintenance, repairs, customer support, all the factory maintenance, machine. Then you're looking at remote technical help, which is again very crucial. So your person coming into like a assembly line, or he's coming into like a maintenance, a lot of this factory work. So you are able to have a remote technical help. One person sitting remotely is able to help multiple plants. So that's how we are able to bring in AR and VR into this. Increasing the worker productivity, although you're also looking at virtual visualization of the manufacturing process. You can actually see, before you do it, you can actually see in the glasses how to do that. So the complete virtual visualization happens over here. Packaging and warehouse. In fact, DHL did sponsored a study wherein like they found that workers actually go and put the package in a different place, and they start looking for that in a different place. So there is a lot of loss of productivity and time because of that. So by using the AR and VR, what they do is they can actually figure out, because they have a small gadget over there, so they can actually go and figure out where exactly they have put the package and pick it up from there, and the productivity increases about 20% because of that. So now a lot of these logistics companies have started using this, and of course the QA. So healthcare is another big market which is used. So all this improved patient expertise, telemedicine, and you're talking of doctor consultation, remote consultation with your expert coming in. Then we are talking of the data visualization, body mapping. In fact, you can do the complete body rendering. So by having a AR glasses, I can do the 3D rendering of the entire human body. So the professor, instead of just looking at a 2D picture or like a presentation like this and explaining, he can actually walk around because the body is rendered, and the students can actually visualize what the professor is telling. They can look at each and every part of the body, they can do that. So those kind of data visualization, body mapping can be done using AR and VR. Then we have got this interactive patient information. Then we are talking of like advanced diagnostics, risk assessments, surgery assistance. So a lot of things there. So how is AR and VR shaping up? I know I have got very less time. I'll just rush through some of these things. So I think Tucson is known for optics, and I think AR and VR, one of the main things here is the optics. So we are talking of monocular, binocular displays, micro displays, projection displays, waveguide. Everything is only optics, and it's all about optics over here, because that forms the core of AR VR. And AR is getting adopted in artificial intelligence. So you're talking of like things like Snapchat and things like that, where you're actually putting like a bunny ear or like a doggy ear kind of a thing you can superimpose on your face. So this is actually a combination of AR and AI. So those kind of a thing, augmented reality with artificial intelligence. So built-in eye tracking, so you can actually wear a AR glass and look around. So you are actually, that glass is moving around and you can see the picture the way it is there. Then completely natural hand coordination. SLAM is a very important thing. Basically, SLAM is simultaneous localization and mapping. So if you're having your Zumba robot, some of them cleaning your home, basically your SLAM is the algorithm which is there, but you are having the same SLAM is integrated into the AR also. So I'm having a small presentation about how it is used in a real life scenario.
Job started.
Directions.
Walk 50 feet, then turn right. Warning, confined space. Panel located. Enter code 7 to initiate relay. Disable active circuits. Disconnect cable. Remove unit.
This whole problem with lights is being fixed.
Call Phil.
Calling Phil.
Yeah, this doesn't seem quite right.
Let me take a look, I'll take you through it. Hit the relay button.
Okay.
Then 784.
Got it.
Yeah, it doesn't seem quite right, but it'll be okay for now.
I'll put a new work order in for next week, Phil. Thanks for your help.
New work order submitted.
So you can see that how a remote technical help was useful in with AR and VR in a real life situation maintenance. So there are some benefits and there are some things. So interactive hands-free instructions. So as you saw in the video, how he was able to carry out the work and envisioning the hypothetical things in reality, like somebody expert technical help helping from far away. That's becoming reality now. Virtual co-location, immersion, and then there are definitely some challenges like consumer is not the place. People are not going to pay $2,000 or $3,000 for these AR classes buying that. This is basically for the B2B, this is for the industries. Then unavailability of this dedicated operating system. We are still making use of things like Android, the cell phone operating system for this. We need to have a separate operating system for AR, VR, and the ecosystem. We need to have the apps. We need to have more people developing apps for the AR and VR, and we need to have a dedicated silicon. So Qualcomm is the first company who is coming up with a dedicated silicon, but we need to have more in this. So this was my small presentation on the AR, VR. I'll be around here if anybody needs anything. Thanks so much.